Good day to you all, and welcome to this presentation on Smart City Citizens Service Provision using participatory design and participatory sensing, in which we will be offering lessons for developing cities. The motivation for the paper is premised on the notion of involving citizens in public affairs through a process of both participatory design and participatory sensing, which is a new emerging theme in the Western world. This, in turn, would contribute to the realization of successful e-government applications due to the fact that citizens are involved in the design of artifacts which affects their involvement with government. Participatory design and participatory sensing through Internet of Things devices use data, information, and information sharing, which are key aspects of development in globalized economies. Moreover, participatory design and participatory sensing does offer a promise for a fair balance technical and non-technical perspectives on citizen requirements. The problem at hand is that e-government developers normally get inclined towards technical requirements and downplay citizen requirements into the design of artifacts. So in this regard, smart city digital models, which are premised on participatory design and sensing, hold the promise of improving resident service requirement and delivery. This paper is premised on three research objectives. The first concerns the assessment of the policy environment of smart city digital initiatives for developed and developing contexts in order to benchmark lessons that can be learned from the implementation of Internet of Things for emerging cities service delivery. 2. To evaluate the available Internet of Things architectures that form an impetus for deploying of smart city IoTs for citizen service delivery in developing contexts like Uganda. Thirdly, to present a participatory design and participatory sensing framework for IoTs in developing context smart city implementation. The methodology of this paper is based through, firstly, a systematic literature search, policy analysis, and aligns to empirical participatory design results which were obtained from a previous study, which in turn informs smart city initiatives in a developing country context case study. The results that informed this project are from the 4 co-design research iterations, which we refer to as 4 co-Ds. These include co-problem discovery, co-problem definition, co-development, and co-delivery, with the co-design team members in 4 full-round iterations and with citizens being involved in another 4 full-round iterations. The survey ideation data was collected among 425 citizens who operate small and medium enterprises within Mukono Municipality, Uganda. The outcomes are derived from 4 policies that were analyzed. The German Digital Strategy 2025, the City of Cape Town Digital Strategy, the Kampala Capital City Authority Smart Strategy, Washington DC Smart Strategy, and the Barcelona Smart City Strategy. Implicit in these policies, we identified the following. 1. A commitment to ICTs for efficient and effective administration of the city in the provision of services to residents and citizens. 2, an offer of free Wi-Fi to citizens, taking into account both access and affordability challenges that prevail, citizen-centric designs in place, traffic management systems, waste management, smart traffic light systems, which, for example, sets the traffic lights at green until emergency vehicles pass, emergency response devices installed in individual citizens' homes and connected through either a land or mobile telephone to a call center, which can be contacted at the simple press of a button, as well as various other innovations. In Uganda as well, there are various innovations that are identified in their strategy, such as aerial geomapping, their national backbone infrastructure for the creation of a ubiquitous network, technology for city surveillance involving police, a secure private cloud for hosting citizen applications, free Wi-Fi hotspots which are in planning, CCTV cameras for monitoring crime and enhancing citizen security and compliance to public health issues, e-procurement and e-tax. So, what are the learnings from the smart city policies that were analyzed? Well, first and foremost, that participatory sensing is based on public participation or participatory design. It has been observed that involving the public, especially the citizens, in public affairs like smart city design using participatory sensing applications is key to the realization of e-government and mobile government. In respect of participatory sensing, it is important to note that it is the citizens who make the decisions about what, where, and when to sense. As such, the lessons for developing cities is that they need to adopt a citizen-centric approach in order to meet their citizens' aspirations amidst the many competing priorities. Governments, therefore, must align citizens' aspirations with their commitments as articulated in their smart city strategies. So what are the IoT architectures that form an impetus for the deployment of a smart city? In this regard, we want to stress, first and foremost, that the mobile device is the primary device that would underscore the realization of a smart city objectives. So there are a number of architectures that are identified, and first and foremost we identify Bluetooth enabled phones tagged with RFID labels. Secondly, portable digital assistants. Thirdly, Bluetooth nodes. Fourthly, RFID antennas and readers. Fifthly, sensor smart boards. Sixth, Bluetooth access points. Seventh, RFID tags. Eighth, global system for mobile communication masts to enable communications across the network. And lastly, a business intelligence database for analytics, which must be enabled in order to realize value from the collective data. So, what are some of the implications from the IoT architectures that have been observed? Firstly, we note that the opportunity of intelligent systems to make cities smarter in developing contexts lies primarily in the way mobile phones are harnessed together with, firstly, RFIDs, right? And then wireless sensing networks, which are integrated in urban planning to improve the information value chain. It is observed that currently in developing contexts, devices are still standalone with very little interconnection. And this needs to be addressed. And furthermore, that a citizen-centered approach is really critical during design to enable participatory sensing to take place. Okay, so here we present an Internet of Things participatory design and participatory sensing framework for developing contexts. There are 4 layers. Firstly, the sensing layer, which comprises the various architectures that have been identified. Then the transmission layer, comprising both the transmission network and an access network. The data management layer, to enable both the efficient collection and management of data and conversion into meaningful intelligence. And lastly, the application layer, which comprises various applications that deal directly with matters that affect either the social or economic well-being of the citizen. The first conclusion we make in respect of the framework presented is that the onset of participatory sensing is participatory design, and this involves collective design and involvement by citizens and other stakeholders throughout the project life cycle, which incorporates co-problem discovery, co-problem definition, co-development, and finally co-delivery. In the paper, details are presented of a use case which is presented as an exemplar for incident reporting through participatory sensing. From a participatory design and participatory sensing perspective, Internet of Things need to be designed from a human-centered view rather than a purely technically oriented one. IoTs have been likened to the human nervous system with an analogy of connectivity and interaction of data and data nodes to the brain as the main processing unit. So as such, 3 major processes that take place in the central processing server are identified. These are derived from the situation awareness theory. Firstly, perception, which is an attention-based selection of task requirements. It includes affordances, which implies how an application should be used, consistency, familiarity, recognizability, visibility, and benefits expectation. Secondly, comprehension is an understanding of perceived information about a particular situation. So it includes, for example, learnability of the system, association, generalization, information value, and ease of use. Thirdly, projection includes feedback, user-centeredness, the extent of support, the use of interfaces that inspire user confidence, meaningfulness, prediction, pop-up messages, signal displays, and error functions, amongst others. In closing, we'll briefly describe a use case of human-like IoT architecture for a cloud-based citizen healthcare management scenario. Within e-government and the health sector, one component for making cities smarter is improving the turnaround time for providing healthcare. This is because long turnaround time makes healthcare giving centers clouded, noisy, and unpleasant, and as a result, negatively affecting the quality of services that are provided. The huge amounts of data that can be generated from various sources can reside in the cloud, which requires greater processing power to retrieve information in a secure and reliable manner. From Internet of Things, such data can be generated and then accessed by any caregiver in various locations within the country and beyond. It is to be noted that the propositions in the paper are subject to further implementation and validation in respect of low-cost wireless sensor network devices using participatory design and participatory sensing while taking a socio-technical approach. Thank you very much for listening.